Thanks, everyone. We never set out to design equipment. We actually, or I set out to design a process and to fix a problem. I'm a bit of a fan of the Toyota production system and lean manufacturing, and they talk about removing waste. So we sat down and said, right, what are some of the biggest wastes that we have in a mining process? And in its most fundamental level, the one I came up with was time. But it's the only one you can't get back. You can buy more gear, you can get more people, get more capital, whatever it is, but once time's gone, it's gone. You might think you can make it up, but you don't really. That's just an opportunity cost for later on. These are two of the most annoying icons or graphics that I ever look at. And to me, that's complete and utter waste of time. It's inefficient, we're waiting around and nothing's happening. My past, I started as a coal miner underground and I guess worked my way out of the mine, so to speak, became a mine manager and whatever. And these were some of the sentences that we used to get all the time. Oh, I've always done it this way, or can't we just keep life simple? Why do you want to have to unpack everything all the time? My mining nickname is Sparrow, probably because they flit around with too much energy, not achieving too much, but it's certainly frustrating. So the first area, and my background's predominantly underground, was a typical underground coal mine. And when I sat and looked at it, we take the most amount of jobs, the most amount of people, the highest risk activities, the most amount of mobile and diesel equipment, and we stick it in the most congested part of the pit, and we expect it to perform. And then when it doesn't, we all sit together the next day and we scratch our heads and look at each other and go, oh, okay, we'll do it better next time. But we do it every time as if it's the first time we've ever done it, and it doesn't improve. And you come to conferences like this, and we talk about the same sort of stuff. So we decided to look at it from a process point of view, not from an equipment point of view. Process isn't nearly as sexy or exciting as looking at new equipment. So basically what we did is we took as many of those tasks and as many of those jobs that are typically done at the in-by end, and we moved them out. So the guys and girls at the face, they are there to cut coal, and that's it. All of those other jobs, wherever possible, get taken out and divorced from the process. This was a mine that I was loosely associated with, thank God I wasn't the manager, but that's how they managed their conveyor structure. Came out from underground, was tipped in a pile, guys at $70 an hour on overtime, spent all shift sorting through it, and paid a contractor $3 million a year to drive out from town to pick it up, fix it, straighten it, clean it, and send it back to the pit. And ultimately, conveyors, whereas I guess the bit of equipment we chose, have not really changed forever. It's still a big rubber band rolling along on idlers. So we decided to do something about that, and certainly in an underground mine and in a different set of circumstances for an open cut, there is a hell of a lot of lost time. We tend to look at the major delays that we report, but it's a little bit like an iceberg. There's a whole lot of inefficiency that we have built into our processes that we don't measure. We just accept that, well, that's mining and that's just part of it. So there's this artificial glass ceiling that we've imposed on ourselves, and we're trying to break that. So red line is our first system, I guess, in solving this. There's some major components to it, but essentially it is like a normal underground conveyor, so it's not like a mine has to go and repurpose their whole operation. They can use a lot of what they already have, but there's some IP in some of the components that we've designed. Essentially, rather than the conveyor being a fixed bit of equipment that's either hung from the roadway roof or mounted on the floor, it drives along a monorail that's hung from the roof. And by that, and multiples of them together, the system can drive along the monorail and operate as one continuous conveyor. So rather than having to extend it and make it longer or shorter, which is a normal part of the mining process, at the in-by end, which ultimately stops production, we can do that from the out-by end without stopping production. So all of that time is brought back. There's a hell of a lot of manual handling and other safety and cost benefits as well, but really the extra production time is the big one. There's a height adjustment mechanism as shown there, so you can grade the belt up and down. They say the simple ideas are often the best. The height adjustment mechanism isn't too dissimilar from a Hills hoist, the clothesline. We were living here in Sydney and I was teaching the kids to swing around on the line and I fell against the handle, and yeah, that was the solution. Simple, but it works. The rollover idler is a second bit of equipment that we've come up with, and this allows idlers to be changed on a conveyor without having to stop it. So it's not just for an underground conveyor, but any surface conveyor in any other industry. The whole idea, rather than a lot of systems where you have to reach into the conveyor and install something to lift the belt up off the idler that's failed, the idea is that the idler comes away from the conveyor and the conveyor stays as it is, but it's replaced and removed and changed from the safety of a walkway or away from the operating conveyor. This is a pretty image, I guess, of the installation recovery centre where we make the conveyor longer and shorter. So this is out by in the panel, so away from the production area. And from that point in, so up the page, the conveyor drives along that monorail and operates as a full, complete system. And the reverse during production when the conveyor is coming back out. Some more pretty pictures of a typical underground mine. And that's the rollover idler in its rolled over position, I guess you could say. So in terms of what's the impact for a company, pretty significant. We ran a model last week for a client that we're discussing with, and on their operation, they expect to be able to cut about 25% more coal a year without any extra expense. So it is a significant amount of money. And at the moment, coal price, depending on the product or whatever, can be several $100 million a year. So needless to say, they're fairly interested. Or in the other part of the cycle where prices aren't as high, you can reduce costs. Our other system is a container conveyor. This is more aimed at surface power generation, ports, open cut mines, that sort of thing, and certainly not just coal. The container conveyor really is designed to fix the problem of fixed infrastructure. So at the moment, conveyors are regarded as fixed assets. Once they're in place, they're there. They're concreted into the ground, they're built by hand. You can't really recover them, and if you do, they're not really worth much, and they cost a hell of a lot of money to move. And certainly in New South Wales, regulators are now making you fully rehabilitate the prior site, so you can't just bury them like we used to. They've actually got to be physically taken away and disposed of. So how do we do it? It's the humble shipping container. So the shipping container is fitted out with the conveyor at our manufacturing facility, and it arrives to site in a plug-and-play format. So any options that you choose, be it pipes, cables, lighting, fire suppression, whatever, walkways, is all fitted out prior to arriving at site. So it is a registered shipping container. It is transported to site as a shipping container and then becomes its operational framework, I guess. We can span up to 2 modules at the moment, so 80 feet between foundations, so perfect for gantries and that sort of thing. We're working on a major international airport at the moment with this system, and it had to be fully enclosed because they're transporting fly ash and cement powder, and this is essentially a view of the system that they're looking at obtaining. The sides of the container are able to fold out if you want, and to provide an external walkway, which can be fully covered. Very, very simple. There's no rocket science in any of it. There's a hell of a lot of engineering in it, but there's nothing tricky about it. But again, it's trying to address those fundamentals of time. So in this instance, the time to install an overland conveyor is usually fairly significant, and operators will want to truck product or truck material while the conveyor is being built. Because it takes so long, and usually where they are, they cost a hell of a lot. These being modular, you can pick them up and reuse them very, very inexpensively. They're the first two modules being built overseas. And as I said, there's really not a hell of a lot to them. It's a fairly simple concept, but I think that's what people like. That's me. Any questions? Yeah, sure.
Really enjoyed your presentation.
Thank you.
The containerware seems to me, after you put the modules together, putting the conveyor is more work than the traditional. Like
No, it's the same. It's just pulled along. Pulled along
You
as normal.
do it from one end to the other.
Just a winch
Is that
as
how
you
it's
install.
done in the regular?
Yeah, yeah. Our other version, every module is its own conveyor system. So you could go around right angles or up steep gradients or around an obstacle or whatever. So like a cascading system.
So this design will make it easily. You can move it from one location to another.
Absolutely. Yeah, absolutely. So there's an operation in WA we're talking about. They buy a new conveyor every 2 years because their pit moves so fast and because they're not worth anything to recover. This, they will only have to buy two for the rest of their life of mine. And they just leapfrog them.
One more question. I mean, I know that conveyors are known for safety concerns. And the part that you show in the underground mine, you can continue operating and it just worries me. It's going to be some safety concern there.
The whole point is that you can do it away from the conveyor. Some companies will choose not to touch a moving conveyor at all, no problem. But even so, with that system, the time taken to replace a failed component, or even just wind it away from the belt so that it's not going to cause any damage, is a significant improvement from now. Yep. And combined with monitoring, it's perfect. Yep.